Now let us discuss about EMF in a rod rotating in a magnetic field. Suppose we have a magnetic field here. It's perpendicular to the board. That is normally going into the board in this way. And let me represent it by cross signal. So this is a magnetic field going into the board, and here we have a rod of length L, and this is the center where about which it is rotating. This rod is rotating about this center, and its length of this rod be suppose L. This is suppose L, and it is moving, it is rotating in this way, in this magnetic field, and after time t, suppose angle subtended by this rod at the center, suppose theta, d theta, sorry, not theta, so d theta. After time t, so angle subtended by this rod be d theta with its initial position after time dt. Okay. Now, what will be its angular velocity? Suppose let a rod of length L. So let me write the topic here. Rotating rod in a magnetic field. So let a rod of length L be rotated in a magnetic field. B. In a first that in time dt, it moves through an angle d theta. So it moves through an angle d theta in time dt, right? This way. Now its angular velocity, therefore its angular velocity is given by omega d theta by dt, right? Omega d theta by dt. So when it complete one rotation, in one complete rotation, so in one complete rotation, the angle subtended by the rod at the center will be 2 pi, right? Because the circumference subtends angle 2 pi at the center of a circle, right? So angle through which it will move after one complete rotation, it is twice pi. So in one complete rotation, twice pi. Area, what will be the area it will cover? Area covered area covered is pi L square, right? So area covered in one complete rotation, that is twice pi, is this one. So when it moves through angle 1 degree, so in 1 degree rotation, so what will be the area covered? Area covered in 1 degree rotation, its area covered will be pi L square by twice pi, and here pi cancel, so we will get L square by 2, right? So if in rotation through twice pi, the area covered is pi L square. So in unit degree of rotation, the area covered will be this area divided by twice pi, that is L square by 2, right? Now for d theta, when it moves through d theta, then area covered will be dA, that's going to be equal to theta into area covered through unit angle L square by 2. So that will be the area, change in area when it moves through an angle d, right? So now what will be the magnetic flux? Magnetic flux linked with this rule. Flux is given by phi is equal to B dot A. B vector dot A vector. A is area vector, B is magnetic field. So this B is magnetic field, right? Magnetic field, and A is area vector. Area vector. So now here you see area of this surface is facing in this way, like this, suppose. So its area vector should be in the same direction as B, right? So therefore angle between these two, angle between B vector and A vector is theta is equal to 0, and cos 0 degree is 1, and B dot A, the dot product of two vectors, suppose we have two vectors A vector and B vector, their dot product is given by magnitude of A and magnitude of B cos theta, right? So that's why here we will get B dot A cos theta, B dot A cos theta, and cos theta, here you see theta is 0 degree and cos 0 1, so that's why phi will be, so therefore we will get phi is equal to B, that's what we will get. Now induced EMF E, that's equal to here we are considering only one turn. Suppose this is a circular loop of one turn, consider that way, then that will be minus d phi by dt. Now as we have got phi is equal to BA, now replace this phi by this value, then what you will get? Then you will get minus d by dt of BA, and magnetic field B is constant because we are applying here uniform magnetic field. Okay, remember that. So that's why B is considered to be a constant. So we can write minus B dA by dt, right? So now this dA is nothing but theta L square by 2 or half L square theta, you can write, right? Now in this case this L, length of this rod is fixed, right? So that's why we can write here variable is theta only, so that's why we can write, if you replace this dA by this value, then what you will get? Minus B L square by 2 d theta by dt, because this L is fixed, that's why this is not written here. Okay, so you can take it out of derivative, right? Now d phi by d theta is what? This is the angular velocity. Now replace this one by omega. So then you will get phi is equal to, sorry, not phi is equal to, E is equal to, it implies EMF is equal to minus B L square omega by 2. So this is the expression for EMF, or you can write half B L square omega. So this minus sign comes from Lenz's law, and if you need to find the EMF only, then you can ignore this minus sign. Remember that. So this is the expression for EMF in a rotating rod in a magnetic field. Hope you have understood this.